Hello friends, welcome back to this video which will discuss about the rest of the four algorithms. The third algorithm is greedy algorithm. First we'll look into the definition, which the algorithm that makes the locally optimal choice at each step with the hope of sorry okay makes the locally optimal choice at each step with the hope of finding a global optimum solution. Okay. Diving deeper, a greedy algorithm is nothing but a problem solving strategy that makes the local optimal choice at each step with the hope that these local solutions which will lead to a global optimal solution. So whenever there is a possibility at each step, this algorithm will look for a optimal choice so that this will lead to the final global optimal solution. So what are the key characteristics of this greedy algorithm? Key characteristics. Greedy choice property. A global optimal solution can be arrived by choosing the best option at each step. So what is the possibility of getting a global optimal solution is that it should opt for a best choice at each and every step. First one is that greedy choice property. Greedy choice property is the first key characteristics, and second one is optimal substructure. Optimal substructure. Okay. So what is optimal substructure? Optimal substructure is the solution to a problem containing the solutions to its sub-problems. So by opting this algorithm, what are we finding out? That the solution to a problem which also contains solutions to its sub-problems. Okay. So what are the steps involved in this greedy algorithm? Making a choice that looks best at that instant moment. Repeat the process considering the remaining problems. So instant best choice and repeating it for every problem. Okay. And then combining all the choices to obtain a final solution. Combining all choices. Okay. These are the steps involved in greedy algorithm. So what are the examples? Famous examples of greedy algorithm are activity selection problem. Activity selection problem is one example. Activity selection. And second is fractional knapsack problem. Third is Prim's and Kruskal's algorithm, etc. These are the famous examples. Now, next, moving back to dynamic programming, we'll just read out the definition of dynamic programming. Solves complex problems by breaking them down into simpler sub-problems and storing results of the sub-problems to avoid redundant work. For example, Fibonacci and knapsack are the examples of dynamic programming. Okay, so diving deeper. Dynamic programming is an algorithmic technique used to solve complex programming problems by breaking them initially down into simpler subproblems. So it initially breaks down the problem into breaks down problem into simpler sub problems. Okay, and solving the sub problems each only once. It will solve each problem only once and then finally stores them into a tabular form or array form, table or array. So what are the key characteristics? So looking down into the key characteristics of dynamic programming, first is optimal substructure. Optimal substructure. It is nothing but the solution to the problem can be composed of solutions to its subproblem. Final solution is obtained by combining the solutions to its subproblems. That is called optimal substructure. And second one is overlapping subproblems. Overlapping subproblems. The same subproblem are solved multiple times. Sometimes there is a chance of solving the same subproblems multiple times. And third one is memoization or tabulation. So memoization or tabulation. This process is nothing but results are stored to avoid redundant work or computation. Memoization is tabulation is nothing but storing the solutions so that there is no redundant work or calculation. Okay. So what are the two main approaches of dynamic programming? Two approaches, that is top down and bottom up. Top down is nothing but memoization and bottom up is nothing but tabulation. What is the process going on in tabulation and memoization is that memoization uses recursion. Here in memoization it will use recursion and store the result as and when they compute. Using recursion it will store the result as and when compute. And tabulation is solve and store the smallest subproblem first, building upon to the final solution. So after dividing this into smaller subproblems, it will start storing the optimal solutions for the first smaller subproblem, building it up to the filing it up to the final solution. Okay. So finally, in both the approaches, we will store the solutions so as to reduce the redundancy and rework calculations, okay, for future use. So examples of this dynamic programming are Fibonacci series, Fibonacci, knapsack, longest common sequence, matrix multiplication, etc. are the examples of dynamic programming. Advantages of this dynamic programming are efficient for problems with overlapping subproblems. For example, if there are overlapping problems, similar problems, overlapping problems, so in that case we can reuse as we are storing the data. In both top-down approach and bottom-up approach, we can use the same solutions when they are stored in table or array form. And second advantage is that ensures optimal solution. So what is the goal of every algorithm is that we have to obtain the optimal solution. Okay. These are the two advantages of dynamic programming. First is overlap. If in case we have overlapping problems, we can reuse them, the data stored in table or array. And the second one is optimal solution, which is the goal of each and every algorithm. So next one is recursive algorithm. First we'll look into the definition of the recursive algorithm, that is calling itself with a subset of original problem. Okay, calling itself with a subset of original problem. We'll dive deeper into the algorithm. Sorry, we have missed the fifth one, that is backtracking, which is an important algorithm. So backtracking is this algorithm tries possible solutions and backtracks when the solution path fails. So as the definition implies, for example, this algorithm tracks first divides it into steps, and if this solution of the step 1 is correct, then it will move forward. If the solution to the step 2 is not correct, then it will backtrack or delete this solution and then move forward to the another step. Okay, this is called backtracking. So backtracking is nothing but a problem solving technique that builds a solution incrementally. So as we are discussing that this goes on incremental process. If the solution to the first step is correct, then it will go on adding to the second step. If the second step solution is wrong, then it will backtrack and then go on to the third step. The solutions go on keep piling, so it is called incremental, one piece at a time, and abandons a path or backtracks as soon as it determines that this path does not lead to a valid solution. If this path does not lead to a valid solution, they will backtrack or abandon it. Okay, abandon the solution. Key characteristics: depth first search approach, tries all possibilities but prunes those fails. So it will also try all the possible solutions but prunes the solutions that fail. It will not count the solutions that will fail. Often used for constraint satisfaction problems. So what are the steps involved in this algorithm? Choose the possible option. First we'll choose possible option. And then move forward. Third one, if the choice leads to a solution, we'll keep it. If the choice is our solution is positive, we will keep it. If it is not a possible solution or negative solution, we will backtrack or abandon it. Okay. Trying for another option. So these are the steps involved in backtracking algorithm. Okay, examples of backtracking algorithm involve Sudoku, maze solving, subset and permutation generations. These are all very famous and common examples. Sudoku, maze solving, and subset and permutation generation. So one more advantage is that this is more efficient than brute force algorithm. Compared to brute force algorithm, this is very effective, but can be slow for larger problems without good pruning. If there is no good pruning process, can be inefficient or slow for large problems. Okay, inefficient for large problems in case of bad pruning. Often exponential in time complexity. Sometimes this also may take time. So the final algorithm is a recursive algorithm. So recursive algorithm calls itself with a subset of original problem, for example, factorial tower of Hanoi. These are the examples for recursive algorithm. We will look deeper into this algorithm and close with this video. So recursive algorithm. A recursive algorithm solves a problem by calling itself, we know very well, with a smaller input, breaking the problem into simpler subproblems until it reaches a base case, which is the heart of the recursive algorithm, because without the base case, it may turns out to be infinite loop. So, what are the key characters? First key character is it will call a function, calls itself. This is the key characteristics of recursive algorithm. Second one is must have at least one base class. At least one base class to prevent infinite loop or recursion. To prevent infinite or recursion. Okay. And third is solves the same problem repeatedly with smaller input. So with only smaller inputs, it will solve the same problem. Okay. Structure of recursive algorithm. It should definitely have a base class, as we have already discussed. Otherwise, it will go on to an infinite or recursion loop. So first and foremost, it should have a base class, a simple condition. What is a base class? A simple condition where the function returns without calling itself. Okay, this is the final call where the function returns without calling itself. Recursive case, the function calls itself with a modified input. So there is a case for recursion, there should be a case or an input. So that is called recursive case. So examples of this recursive algorithm are Fibonacci, factorial, very famous example, factorial. Tree traversal is one more example. So what are the advantages of this kind of recursive algorithm? This is very simple and elegant. Yet elegant, and ideal for problems that naturally fit recursive definition. For example, tree structures and all, these come under natural recursive definitions. So this is ideal for all these natural recursive definitions, like tree structures, tree traversals, etc. Tree structures and tree traversals, all these comes under recursive algorithms. So what are the disadvantages of recursive algorithm? Can lead to sometimes stack overflow for deep recursion. In case of deep recursion, there is a chance of stack overflow and may have repeated calculations, can be optimized with memoization or tabulation. Okay, this may have repeated calculations. Already we have discussed the concept of memoization and tabulation. So we can optimize repeated calculation using memoization and tabulation, as we will store the results in table or array format using bottom up or top down or bottom up approach. Okay, so by using these we can optimize the repeated calculations. So we'll look into the simple examples of algorithm. So every algorithm, the first step would be start and the final step would be stop. This is a thumb rule. Then we are reading two numbers A and B. We are adding A and B and storing the total in the sum variable, and we are printing the variable sum to the screen, and finally we are stopping the algorithm. Okay, this is the basic example using the numbers. So we'll go for real world example, recipe for making tea. As we have already discussed that algorithm is nothing but a recipe to complete a problem with a specific task. Okay, is nothing but a recipe. Algorithm itself is a recipe. So we'll take a real world example of recipe for making tea. First we will boil water and then add tea leaves, add sugar, milk, simmer for 2 minutes, strain and serve. These are the steps for making, algorithmic steps for making tea. Okay. So what is the importance of algorithm and why is it important? Algorithm important because they form the core of computing. They help us solve problems efficiently, save resources and write optimized codes. From data science and machine learning to networking and robotics, algorithm powers almost every field of technology today. So now here comes a question, what's the difference between an algorithm and a program? An algorithm is a logical plan, it's language independent. A program is the implementation of algorithm written in specific language like Python, Java or C. So diving deeper into this table, so we have discussed about what is algorithm. Now we'll look just brief about program also. So in the perspective of definition, algorithm is nothing but a step-by-step procedure or task for solving a problem and its subproblems. What is a program by the definition? Implementation of the algorithm. So program is nothing but the implementation of the algorithm in programming language. So it is different for every different language. C, C++, Java, Python, etc. The implementation of the algorithm is different in different languages. So what is language? Based on the aspect of language, what is an algorithm? Algorithm is language independent. For every or any language, algorithm remains the same. Okay, and written in programming languages like Python, C and Java. So programming is done syntactically different for each and every language. Syntactically different for each and every language. Purpose. From the purpose aspect or purpose point of view, what is an algorithm? To design a optimal solution is the final goal of the algorithm. So what is the purpose of the program? To execute the solution on the computer. So finally, if we are writing a program, it should run without any dynamic errors or runtime errors, so on. There are many number executable errors, so on. There should be no error and it should execute properly on the computer. Okay. Thank you.